Hello, this is Lazarus at telecom.Tech, where telecom and networking technologies are simply explained. Today we'll be simply explaining Open Shortest Path First, or OSPF. This is the first of my new series of videos on OSPF. If you want to be informed of every new video that comes out so that you can follow along, please subscribe and enable notifications. And if you like this video, please like this video. And don't forget to check out my new website at telecom.Tech.io. You'll find the link in the description below as well. There you can subscribe to my newsletter to get updates to new content in your inbox. I promise I won't spam you. I'll only send useful and engaging information. And soon I'll have even more in-depth courses with labs, configurations, and more complex network topologies that will be published on my site. So stay tuned for that. Now let me share with you a very vital piece of information for those of you that may already have experience with OSPF. Now, just because you know how to configure it doesn't mean you know OSPF well. If you're serious about becoming a really good network engineer, it's not enough to just know the commands. I originally learned OSPF and used it for years, but it was only when I went back to study it again that I realized how many gaps I had in my understanding of the protocol. And when I went back and studied it, only then did I truly appreciate its elegant design and capabilities. OSPF is easy to configure. You can teach a 10-year-old to do it, but it's hard to understand the intricacies of how it works. And that's what makes the difference between an average network engineer and a networking guru. Such intimate knowledge of the protocol is required, especially for network design and architecture, as well as troubleshooting. And this is all the more important when you deploy OSPF along with other technologies, such as MPLS, traffic engineering, redistribution into other routing protocols, as well as the various network topologies and technologies that you may use. Complexities increase exponentially, and if you don't understand why OSPF behaves the way it does, it becomes very difficult to do your job well. So my point is, even if you know OSPF, going over this series will be helpful to fill in the gaps, to gain understanding that will give you that light bulb experience. If you're new to the protocol, all the better. You can get started right from the very beginning. Don't underestimate the power of obtaining comprehensive knowledge and understanding of the OSPF routing protocol. So let's get started. In this first video, we'll be looking at an overview of OSPF. Let's first take a look at where OSPF fits in to the whole dynamic routing protocol landscape. Here we have the most common routing protocols used with IP networks. OSPF is an interior gateway protocol, or IGP, and belongs to the link state routing protocol category. OSPF shares this category with the intermediate system to intermediate system, or ISIS routing protocol, which is another link state routing protocol that is extensively used in today's networks, and especially within ISP networks themselves. Now, OSPF is an IGP, as we mentioned, which means that it is typically deployed within an enterprise network and within a particular autonomous system. In other words, the network in which it is deployed is typically owned and operated and administrated by a single entity. It belongs to the link state routing protocol subcategory. This category of routing protocols uses what is known as the shortest path first, or SPF algorithm. This is officially known as Dijkstra's algorithm because Edgar Dijkstra, a pioneering Dutch computer scientist, developed it back in 1956. Then it was just a mathematical algorithm, but OSPF adopted the use of that algorithm to do its job. We'll devote a whole video in the upcoming weeks just on this algorithm to see how it works. Another interesting characteristic of link state routing protocols like OSPF is that each router in the topology maintains a map of the entire OSPF domain. This map is called the Link State Database, or LSDB, and it's used by each router to independently calculate the best path to every destination in the network. Now, OSPF, like all dynamic routing protocols, forms adjacencies between OSPF-enabled routers on the interfaces that are enabled with the protocol. These adjacencies are created automatically by the sending of multicast hello messages, essentially saying, I'm an OSPF router, I'm here, are there any other OSPF neighbors found on my connected networks? Once they discover each other, OSPF routers go through a series of involved exchanges of messages to establish these adjacencies. If all conditions for making such a peering are met, the routers begin to exchange information about routes that they have learned about. The exchange of networking information uses what are known as link state advertisements, or LSAs. Now, LSAs are a type of message used by OSPF routers to exchange information about the networks they know about. These messages are much more complex than you would find in other routing protocols like EIGRP or RIP, because OSPF routers exchange their whole topology with each other. LSAs contain a lot of information, including the router ID of the originating router, interface and IP addresses, costs to particular network destinations, a list of neighboring routers, the area the router belongs to, which we'll talk about in a moment, as well as the network type for that particular route. There are different types of LSAs used in many different situations. Today, there are 11 different types of LSAs for OSPFs. Now, don't worry if all of this sounds overwhelming. We'll go through it methodically and simply, explaining each concept and topic thoroughly. Now, one of the major advantages that OSPF has as a protocol is its scalability. Now, this scalability is primarily due to its hierarchical design, which uses areas. An OSPF network can be subdivided into multiple areas, each of which is a self-contained routing domain that helps limit routing overhead and speeds up convergence. Routers within an area have no detailed knowledge of routes in other areas. Area border routers connect different areas and facilitate the exchange of summarized routing information, improving efficiency and minimizing unnecessary detail across the network. Now, there are a few rules that must be followed whenever creating these areas. Area 0 is known as the backbone area. All OSPF topologies must have an area 0. You cannot create a single OSPF area and designate it something other than 0. Routers that have interfaces connected to more than one area are called area border routers, or ABRs. All non-backbone areas, in other words, those areas that are not designated area 0, must connect directly to the backbone area. In other words, this translates to each ABR must have at least one of its interfaces within area 0. When we lab this up in the coming videos, this will become even clearer. Now, OSPF offers many additional features that I'll just list here and give you a brief description of. There are so many different features, and they will only become clear when we see them in action in a topology. Now, these include things like the designated router and backup designated router elections, more succinctly known as DR-BDR elections. For multiple routers found within the same network segment, one of the routers is elected as the DR and another as the BDR. The purpose is to minimize the number of OSPF adjacencies required to make the network work, resulting in more efficient convergence and operation. Then we have stub areas. Now, these are non-backbone areas that can be defined to minimize the size of the routing tables in routers found within those areas. Stub areas are those that only have a single exit point, that is, via a single ABR connected to the backbone network. OSPF can also be configured to operate with various network types. Some networks don't support multicast, for example, and thus OSPF cannot function out of the box to create network adjacencies. For this reason, OSPF can be configured to operate differently depending on the network type being used. A whole series of advanced features are also available, including summarization, LSA filtering, virtual links, and many others that we'll be talking about in this video series. We'll also see how OSPF version 2 and OSPF version 3 differ from each other in both what they can support and the way that they are implemented. OSPF version 2 supports IPv4, while OSPF version 3 supports IPv6 as well. But that's not the only difference between them. We'll find out more about these versions in future videos. Now, as I'm going through all these various features, I realize how much more complex OSPF is compared to other routing protocols like EIGRP or RIP. And the more I think about it, the more it makes sense. Because OSPF really offers a lot of options while keeping efficiency, operational optimization, as well as fast convergence a very real part of the protocol. Now, in order to maintain such a high standard of operation, this level of complexity is necessary for the protocol. And that means that you and I, as network engineers, must get to know this complexity well and understand it. And I hope that by the end of this series, you will have achieved that. So that's my intro to OSPF. For now, I hope you found this video useful, and if you have, please click that thumbs up button. And please check out my website and subscribe to my newsletter. You'll find the link in the description below. And don't forget to subscribe to my YouTube channel to get updates to newly published videos. I'm Lazarus at telecom.Tech. I hope this has been helpful for you, and I'd like to thank you for watching.